So this is my project, hard disk prediction circuit Konya. So I've already set it up the required CI/CD pipeline for this. Let's say I make a quick change. So with that change, the pipeline will get executed automatically due to the main branch. Now, while that is happening, I will explain you the thought process behind the project. This is my research file. So I've ingested the data and I'm trying to get familiarized with the data, determining the size and means and null values in it. So I checked if there are a lot of outliers that might affect my data. But in our case, the outliers might be useful, so I've kept them. I also check the means and get the violin plot. Uh, I plotted the numerical values in a correlation coefficient into a plot and checked if my data is balanced. Also made some check. I also checked some distributions of the data. So I've encoded the categorical variables and plotted the correlation. Now to determine if which of these plots are useful, I'm using chi-square test for my categorical variables. So in this case, for 10% threshold, the critical value was 2.2 and it's well below 2.2. So we removed resting ECG. Also perform ANOVA for the continuous variables. Here, the score for resting VB was low. So I've determined those two have to will remove and we will not face much accuracy loss. Um, so perform the trend test split and perform min max scalar. In our case, there's already a lower and upper bound to our most of our data. So I decided to use min max scalar rather than normal. So um, I've I've performed logistic regression along with the grid search, and I'm using these three metrics to determine which of them might perform well. So I've done logistic regression, SEC, decision tree, random forest, KNN, gradient gradient boost, ADA boost, and XG boost. So I've done a similar research on all of them with grid search and determined that in our case, we will be using human in loop kind of system. So it will be best for us to use area under the curve to determine which model is performing good. So for building the application, I've used the following Docker. I'm importing that requirement first so that you don't have to run it over and over again. And installing the project as the dependency. Also, I've used a logger so that we can get the logs for our runs so that we can see what went wrong if something goes wrong. So I set up the following components for ingestion. The data ingestion, I just read the data and then remove the unnecessary columns from it, and then log and keep the trend and test split apart. So this is data transformation. I use the pipelines that are available in SQL. So I've used standard scalar for my number partner and one hot encoder for categorical variable, and I'm imputing them with medium and the most frequent. So here I'm um, saving those encoders and scalar into a file so that we can access those transformations later when we're trying to predict the data. I've also made a model trainer pipeline. Here, this pipeline determines which of the data, which of the model is working based on our data. So because data could change over time, it's best practice that we set a pipeline so that every time the best model can be determined, and we don't have to research every time. So in our case, because I determined to use area under the curve, I'm using area under the curve here to determine which of the model is the best, and I save it to an object that goes in the artifact. So for prediction pipeline, I'm using the following code where I import all of the required preprocessors and data scalars, and then I predict the value. This custom class, I'm using it to store the data that the user will give me. So in app.py, we'll have this data that the user gives us, and then we can put it through the prediction pipeline and then get our answer. So as you can see, the model is declared, and so we don't have to go and deploy it every time. Thank you for watching.